How do Hanning windows improve FFT analysis results? Imagine trying to listen to a song but hearing a lot of background noise. That's similar to what happens in signal processing when analyzing signals with the fast Fourier transform. When you perform an FFT on a signal, you want to see clear, sharp peaks that tell you what frequencies are present. But if the edges of your sampled data aren't smooth, you get something called spectral leakage. This makes your frequency spectrum blurry and hard to interpret. That's where the Hanning window comes in. The Hanning window is a type of mathematical function that tapers the beginning and end of your data smoothly to zero. Think of it like gently fading an and out of a song rather than cutting it abruptly. When you multiply your signal by this window before doing the FFT, it reduces the sudden jumps at the edges. This smooth transition helps to minimize spectral leakage, making the peaks in your spectrum more distinct. By reducing leakage, the Hanning window makes it easier to identify the true frequencies in your signal. The peaks become sharper and narrower, which improves the resolution. This means you can tell apart to frequencies that are close together more accurately. It also helps in measuring the amplitude of these frequencies more precisely, which is important in many applications like vibration analysis or audio processing. Using the Hanning window slightly alters the shape of your spectrum because it emphasizes the middle part of your data more than the edges. But overall, it gives a more truthful picture of the actual frequency content. In real-world applications like controlling machinery vibrations or analyzing signals in telecommunications, this clarity is essential. It helps engineers make better decisions based on cleaner data. Sometimes, to get the best results, engineers use overlapping segments of data, each multiplied by the Hanning window. This way, they can combine multiple measurements to get a more consistent and reliable spectrum. The overlap compensates for the slight reduction in data at the edges, ensuring every part of the signal contributes to the final analysis. In summary, the Hanning window improves FFT analysis results by smoothing out the edges of your data. This reduces spectral leakage, sharpens the frequency peaks, and makes the spectrum easier to interpret. It's a simple but powerful tool that helps engineers see the true frequency content of signals more clearly, making signal processing more accurate and reliable.